Alright, 5.6, interpreting functions. Another practice understanding tasks. So we're taking it further, this concept of connecting the information and the graph and what we're doing. Okay. So we're going to look at this graph and answer these questions. So what is f of 2? Well, remember, in function notation, this f is the name, which is the name of this function, right? F of x here. The number in here is the input. The input is the x value. So together, when we write it like that, we're asking what's the output when the input is 2. So I go to 2, go up to my graph, find where my graph is right there. So my input of 2 gives me the y value, or the output of 6. So f of 2 equals 6. Now if we look at number 2, we're kind of going backwards here. Now we're saying our output is 3. What's our input? So the output of 3 would be on the y-axis, the output. This is like the out, right? The in. This is like the x. This is like the f of x, or the y. So at 3, what's my x value for my graph? 0, because it's crossing at your y-intercept. So x would equal 0. What is the x-intercept? Well, where's it across the x-axis? Right there. So it would be -2, 0, the only place it crosses. Okay, what is the domain of f of x? So domain, remember, is all the x values. So the furthest left we go is -4. So -4, 2, it's continuous, so we go till we get to 6. So -4, 6 is our domain. Okay, on what intervals is f of x greater than 0? Greater than 0 means it's above the x-axis. Well, from that x-intercept till we get up here, it's above the x-axis. So from -2 to 6 is when it's above the x-axis. On what intervals is it increasing? When is it decreasing? Well, it's never decreasing, it's always increasing. So decreasing would be that empty set, or never. Increasing would be the same as the domain, from -4 to 6. We start here at where x is -4. As we go to 6, it's increasing the whole time. Okay, for what values, if any, is f of x greater than 3? So is the output greater than 3? Well, that y-intercept is when it's equal to 3, right? Right here. So is it greater? Yeah, this whole section of the graph is greater than 3. So from where? Well, from 0, that's like the boundary, not included. As it goes to 6, the end, that is when it's greater than 3. So you could write it that way, or you could put, x is greater than 0 and less than 6. That's another way to write it. Okay, so there's that one. Okay, now let's take a look at another graph, actually two graphs, g of t and f of t. So consider the linear graph of f of t and the nonlinear graph of g of t to answer question 9 through 14. Okay, so where is f of t equal to g of t? This is, remember when we talked about systems where they're equal, where are they intersecting? Well, at this point right here, right? So -2, -1. And in this case, they intersect twice, don't they? At 3, 4. Okay, that's where they're intersecting. Now, where is f of t greater than g of t? So in other words, where is f of t higher? Where's it higher? Because that stands for the output, it means our y-axis. Where is it higher? Where is f of t higher? Well, at that intersection point, g of t is now below f of t until that other intersection point. So from the x value to the x value, the -2 to 3, is the interval where f of t is greater. Okay. Now, they want us to do some combinations here. We're adding things, adding some functions together. Okay, and we kind of talked a little bit about that on the frame. So, that we did. So, f of 0. So we go to where x is 0, the input. Well, f of 0 is 1. G of 0 is down here, it's -5. So it would be 1 plus -5, which would give us -4. Okay. Then f of negative 1 plus g of negative 1. Well, f of negative 1 go to negative 1. That f of 0, or f of negative 1 is 0, right? Plus, what's g of negative 1? G of negative 1 is negative 3. 0 plus negative 3 is negative 3. Then it asks which is greater, f of 0 or g of negative 3. Well, g of negative 3 is up here, it's at 4. F of 0 is up here, it's 1. Obviously, 4 is greater than 1, so it would be g of negative 3. Now it wants us to combine and actually graph these two functions together. It says combine them and graph them on this interval of negative 1 to 3. So from negative 1 to 3, so at all of these points, we want to graph our new equation. So it's like we're making a table here. Maybe scoot it down. Okay. We're saying from negative 1 to 3, what would our graph be? Well, we can find what f of t is, right? We can also find what g of t is. Can't write g of t apparently. And we want to add them together, f of t plus g of t. And that's what we want to graph. So we already found some of them, right? F of 0 was 1. F of negative 1 was 0. G of 0 was negative 5. G of negative 1 was negative 3. And we found when we added them together, we got negative 3 and negative 4. Okay, so we just need to do it for the rest. So what's f of 1? Well, at 1, f is 2. At 2, f is 3. At 3, f is 4. So it would be 2, 3, 4. Right? We also know that at 3, 4, that g of t is the same thing, so that one would be 4. But what about at 1 and 2? At 1, we go down to negative 4. Oops, right there. And at 2, we are at negative 1. So what's 2 plus negative 4 would be negative 2. 3 plus negative 1, positive 2. 4 plus 4, 8. So that's what they want us to graph now. So using the green, so at negative 1, we're at negative 3. At 0, we're at negative 4. At 1, we're at negative 2. At 2, we're at positive 2. So we jump up there. And at 3, we're at 8. So we're clear up here. So we've kind of got kind of a similar shape to both of them, but this line is adjusting it, right? So kind of an interesting way of combining those functions. Alright, now we're kind of doing the same stuff, just with a table though. Okay, now it said they're continuous functions, so that's good to know. So g of negative 3. So let's go to where negative 3 is. What's g of x? It's negative 5, right? That negative 3 is the input. The negative 5 is the output, and that's what it wanted. It says for what values is f of x equal to 0? So f of x, there's 0. For what values? 1 and 2. When x equals 1 and 2. What values is f of x increasing? So when does f of x increase? 42 to 30, down, 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 down. Stays the same. Okay, so right here, now we're going up, aren't we? So from 2 to 6 is when f of x is increasing. On what interval is g of x greater than f of x? Well, where is the g, the output, bigger than the f output? Well, g, negative 3, smaller, 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 bigger, right? 7 is bigger than 2. Oops, wrong way. 11 is bigger than 0, 15 bigger than 0, 19 bigger, 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 and bigger. So from 0 to 6, that interval is when g of x is greater. So from 0 to 6. Okay, which function is changing faster in the interval negative 5 to 0? So changing faster, not getting bigger, not getting smaller, changing faster. So from negative 5 to 0, so this interval, these numbers. Well, f of x goes from 42 to 2. So in 5 x's, this is kind of like the slope idea, y over x. In 5 x's, we go from 42 to 2, so we're changing by 40. So our slope would have been 8. So it changed 8. Okay, now g of x, we go from negative 13 to 7. So negative 13 minus 7 is negative 20 for the y, the change in the y value, over the change in the x value of 5, so it's a negative 4. Is 4 faster than 8? No. So f of x is changing because its slope, its average rate of change, is greater than that one. And had this been negative 9, we would have chose g of x. But because a negative or positive, we're not really thinking about that. Changing faster is just the absolute value of it. So 8 is bigger. Alright, taking a look at this last one. Use the following relationships to answer the questions below. Alright, so we've got all these functions here, right? We've got exponential, linear, straight line, so linear, vertical line, so linear but not a function, right? And another linear. So which of the above relations are functions? Apparently I'm already answering number 20. So explain. Well, exponential we know is always a function, and linear is always a function. G of x equals 5 would be a horizontal line of 5 which passes the vertical line test, so function. X equals 4 would be a vertical line of 4 which doesn't pass, so not a function. Alright, find f of 2, g of 2, and h of 2. So remember, when you're looking for the inputs, take the function, wherever there was the variable x, put in our input f of 2. Oh, so this is h of 2. So 2 squared is 4. So h of 2 is 4. Now f of 2. So f of 2 would equal 3 times 2 minus 2. 3 times 2 is 6, minus 2 is also 4. So f of 2 equals 4. Now g of 2. G of 2 equals 5. Is there an x here to change? No. So we just leave it like that. So it's 5. Then write the equation for g of x plus h of x. Okay, so we need to combine these two functions. So h and g. So g of x is 5 plus h of x is 2 to the x. Can I combine these at all? Nope. So that's g of x plus h of x right there. Or you could write it 2x plus 5. Same thing. Okay. Gonna clear our ink here so we have space. Right. Where is g of x less than h of x? Alright. So h of x is exponential. We know it's going to look something like this, right? G of x is just a straight line of 5. So we want to know at what point do they intersect, and then h of x becomes greater. So this whole part of the graph, h of x, is going to be less than, or wait, g of x is less than. Hold on, getting mixed up here. So we want to know from this point on when h of x is going to be greater than g of x. Okay? So to find that intersection point, okay, multiple ways we can do it. A table is probably going to be the easiest. So we'll go 0, 1, 2, 3, 4, see if that gets us there. Let's go h of x. So to the y-intercept, that would be like 1 times 2 to the x. So it would be 1. At 1, 2 to the first is 2. And we're basically, that's our growth, right? We're times them by 2, so it would be 4. It'd be 8. It would be 16. G of x is always going to be 5. So, oops, it's right here at this, in between the 2 and the 3, that one becomes bigger than the other one. Okay? So we could say, you know, it's just going to be a little past 2, but for us we could probably just write 3. So from 3 as we keep going to the right to infinity, that's when h of x is going to be bigger, when g of x is smaller, that interval. Okay, f of x. Where is f of x increasing? Well, our linear equations, f of x would be, what, -2, and then we'd go up 3 to the right 1, up 3 to the right 1. So it's going to keep going a line like that. Okay, linear equations have a domain that's all real numbers, or -infinity to positive infinity. We always go to the left as far as we can, we always go to the right as far as we can. Because we have a positive slope, it's always going to be increasing. So you'd either write all real numbers, or you could write the interval from -infinity to infinity. Okay. Now, last one. Which of the above functions has the fastest growth rate? Okay. Well, is g of x growing? No, it's got a growth of 0. X equals 4. It's not a function, so don't even include it. Y equals 5x plus 1. Its slope is 5. So if we think about a table, for every time we add 1 on the right side, we're going to be adding 5. Right? So 5. Whereas f of x, we're going to be adding 3. So adding 5 is always bigger than adding 3, right? So we know f of x isn't going to be bigger. We know g of x isn't going to be bigger. So it's either this one or this one. Well, this is exponential. How does it grow? We're timesing by 2. Multiplying by 2 is always going to be bigger than that. So it's h of x. Because we're multiplying. And that always grows faster than addition. And there we have it.